11.2 Cis and trans isomers. In an alkene, the double bond is rigid. Now, the importance of the fact that it's rigid is that then there's not going to be rotation around the individual atoms, and it holds the attached groups in fixed position. So the attached groups would be, for example, this group and this other group, and they're in that position. Now then, if we look at what their position is in relation to the double bond, so if I were to draw an imaginary dotted line right here through the double bond, so right here through the double bond, and then we look at these other attachments in their relationship to the double bond, well then, in this case, this and this are on the same side of the double bond. They are on, the upside that we made of the double bond, and so that's called cis. If it is on, so our imaginary dotted line right here, if it is on if they are on opposite sides of the double bond, then it is called trans. And so, if you go on a transatlantic voyage, you go across the ocean. And so this goes across our double bond, and so that's going to be trans 3-hexene. And you may think, oh, there's no difference. Well, there's no difference in the amount of carbons or hydrogens or the double bond. However, they are going to have slightly different boiling points, slightly different melting points, and they're going to have different properties. So there is a big difference, and some of you may have heard of trans fats. And so this is what we're actually in regards to what trans is. And so we know that sometimes trans if we're talking about trans fats, that the trans is not the kind of fat that you want, for example. Okay, but sometimes the cis is not what you want. And so if we look a little bit more, in case the imaginary line that I had draw across the double bond wasn't good enough, if you want to think about it a different way with your hands, in cis-trans isomers, there is no rotation around the double bond in the alkenes. The groups attached to the double bond are fixed relative to each other. So you can make a double bond with your fingers with both thumbs on the same side or on opposite side of each other to represent cis. Notice our thumbs are on the same side. Or if you rotate your hand the other way, then we're going to have that as an example of trans. Two isomers are possible when the groups attached to each side of the double bond are different. So now that we've understand a little bit what sides of the double bond, cis or trans, is, now we're going to be a little bit more, learn a little bit more. So in a cis isomer, the groups, whether they're alkyl groups or whatever, they're attached on the same side of the double bond, which we've already discussed, and the other items, the hydrogens, are attached on the other side. In trans, the groups and the hydrogen atoms are attached on separate sides. So this is just what we learned earlier, but this is using the ball and stick model to hopefully better represent it. Now, let's learn when things are not cis and when they're not trans. Well, if on a particular carbon of the double bond, if the same group is attached to that particular carbon for both of the things hanging on to this particular carbon, if they're identical, then you can't have cis and trans. Why? Because you could switch this the other way and it would be the same. So you can't have cis or trans if the items are identical that are attached to the carbon of one of the sides of the carbon. So this is not cis or trans. Now over here, first of all, they're showing that's the same thing with our bromine, but however, it still wouldn't be cis or trans because on this particular carbon here, you still have hydrogen attached as both of the other things. So if you were to rotate this and switch them, it's still hydrogen, so it wouldn't matter. There wouldn't be a difference. So if there's not a difference, you can't say cis or trans. So they're showing bromine is the same item attached both times to this particular carbon. So that's another example why that wouldn't be. The cis-trans isomers in nature, there are a lot of different examples of when going from cis or trans, that the different pheromones or the different items in our bodies, that it's a really big deal. Insects emit tiny quantities of pheromones, which are chemicals that send messages. The silkworm moth attracts other moths by emitting bombycil, which has one cis and one trans double bond. Pheromones allow insects to attract mates from a great distance. Pheromones do lots of other things, and they allow the bees to emit signals to like alarm. So all sorts of different isomers and what they do in nature. So now we're going to do a little bit of naming, practice a little bit of naming. So this can be, these can represent cis or trans. Why? Because on this particular carbon of the double bond, you have two different groups. On this particular carbon of the double bond, you have two different groups. So then we look at the groups. Oh, our bromine is on the same side of our imaginary, if we were to use our dotted line, they are the same side of the double bond. So because they're the same side, it's going to be cis 1,2-dibromoethene. If they are on opposite sides of the double bond, like we discussed, that's going to be trans 1,2-dibromoethene. So let's look at these and name these and see what you get. First of all, I just really want you to just see if you can identify if they're cis or trans. Okay, well, when we look at this one, I'm hoping you see that it's on the same side, so this is going to be cis. This and this is on the opposite side, so it's going to be trans. Excuse me. And on C, ooh, look, you got chlorine and chlorine. Both of these atoms are the same atoms on this particular carbon, so that means we're not going to be able to say cis or trans. So that was kind of tricky, wasn't it? So when they go and name it, cis 1,2-dibromoethene, trans 2-butene, then just 1,1-dichloropropene.